right, so we are getting into our fourth lesson in chemical reactions. The first three lessons were over writing and balancing chemical equations and bringing out the formula from the words. And from here and till the end of the unit, we're going to talk about types of chemical reactions. So today we're going to learn about synthesis and decomposition. And I want us to be able to identify those two reactions just by looking at the products. By looking at the reactants. And then I want us to be able to predict the products for these types of reactions as well. And we're going to basically do that for all types of reactions in the next units. Okay, so here are the 5 types of chemical reactions that everyone will learn in chemistry. So this is synthesis, decomposition. We're doing 1 and 2 today. And then tomorrow we're going to do single replacement. And then the next day we'll do double replacement and combustion. Honors, you will be doing one more section, and that is oxidation reduction reactions. And that is on your in your honors section in Moodle. Okay. So to predict products, it's when synthesis is when 2 elements combine to form 1 compound. So if you'll notice that you have 1 element and another element, and then they combine to form a different compound. And that's basically it. So for example, if you had sodium and you had chlorine, they will combine to be sodium chloride. So this is obviously an ionic, okay, because you have a metal, non-metal. And it's just like in the naming rules. Sorry, I'm going too fast. Just like in the naming rules, you're going to change when you add sodium and chlorine together. You're going to get sodium chloride, and just don't forget to change that ending. And we learned that in the last unit, how to name compounds. So here's another compound, that synthesis reaction, and it's going to create a compound over here. So you have magnesium, which is the metal, phosphorus, which is the non-metal, and then it's going to combine to make magnesium phosphide. Just don't forget to change that ending. Next example, you will have sulfur combining with aluminum. You do have a metal here, the aluminum, and a non-metal, the sulfur. So it's going to be another ionic compound. And you will have aluminum sulfide. Just don't forget to change that ending. Okay, so predicting products for decomposition. So to predict the products with synthesis, you're just combining those 2 at the beginning. You're going to do the opposite with decomposition. It's going to be a compound that breaks down into 2 separate elements. And we have 3, we have 3 exemptions, weird rules, I don't know. We have 3 things that kind of occur that isn't just simple breaking down into elements. It's when we're breaking down polyatomic ions, but I'll show you each of those 3 in a few minutes. So potassium nitride, you're just going to write literally potassium plus nitrogen. And you just change the ending back to on the non-metal. Okay, instead of "ide," you change the "ide" to its original ending, and then you're done. So these 2 are pretty simple. Here's one of the examples of the special exceptions. I don't know. So when you have any metal, so it could be sodium, potassium, whatever, bonded or in an ionic compound with chlorate, one of the polyatomic ions, you just write whatever metal was here. Whatever metal was here, you're going to write it here, chloride plus oxygen. This ending will always be here, and you just change the metal. So chlorate was here. This is chlorate for the polyatomic ion list, so it would look like, for an example, you have barium chloride, okay? So barium would be your metal here, you just transfer it here, and then you add chloride plus oxygen. Just like up here, this is always part of the product right here. Okay, so chlorate was an exemption, and carbonate is also an exemption, and we're going to look at another one, or not exemption, like I guess special circumstance, I don't know. So whatever metal is here, you just bring it over here, and then this will always be part of the product when you have carbonate over here. So as an example, you have potassium carbonate. So the answer, the product, would have potassium and then all of this. So potassium oxide plus carbon dioxide should be the answer. And it is. So that yellow is always part of the product. Okay, so if this was sodium carbonate, it would have sodium oxide plus carbon dioxide. And then the last special decomposition is when you have hydroxide, a metal mixed with a hydroxide. So for example, if it was sodium hydroxide, you would have sodium oxide plus water. So I'm giving you an example of a transition metal, okay? So for example, if you have a transition metal, don't forget to bring your Roman numeral over here, okay? And then this oxide and water, that will always be here. So with chlorate, you have chlorine and, I even forgot, you have chlorine and oxygen. Come on, I don't like the way they flip around. But anyways, don't forget your Roman numeral. So we have 3 special things, one with chlorate, one with carbonate, and one with hydroxide. They each have their own way the products are made. And that's the oxide plus water, always part of the product.
Okay, I know that we are done with our actual lesson, but I would like to give you guys a couple of example problems. So we just learned about synthesis and decomposition reactions, which is either just like 2 things becoming 1 or 1 thing becoming 2. And then we learned about the 3 special decomposition reactions, which we'll go ahead and look at as well. So these are obviously synthesis reactions. We know that this and this will combine to make 1 thing. So we'll do the first 2 here. So barium and oxygen will combine to make barium oxide. Just don't forget to change that ending. And then magnesium and sulfur will combine to make magnesium sulfide. And all I'm doing is looking at these 2, okay? Remember last unit where I gave you 2 elements and you just had to combine them to make a compound? That's what we're doing here. So we have magnesium. Magnesium is a metal, sulfur is a non-metal. We know it's an ionic compound, so we know we have to look at the charges, which magnesium is a +2 charge, sulfur is a -2 charge, which it doesn't matter the charges, but I will ask you later on the test, you will have to bring these down into formulas. So this would be magnesium plus sulfur would equal MgS, and that would be its formula if you're interested. This isn't what you need to do in the homework, but I'm just kind of showing you in my head. That's where I came up with magnesium sulfide. Okay, so all of these are single replacement reactions. We know because we're combining 2 things. So here are some decomposition practice questions. So we have iron 3 oxide. So what that will end up being is, so iron, you don't have to bring this over, okay? So you would just say iron plus oxygen. Okay, so, oops. So that's how a decomposition would work. Potassium chloride. So you would have, it would just break down into potassium plus chlorine. The hardest part here is, I guess, deciding which ending to use. I don't know, but make sure your non-metal has the original ending. And now let's go to some of those special decomposition reactions. Chlorate, so calcium chlorate, so that has the rule where no matter what it is, it's going to be the metal plus chlorine. Change the ending to ide, so the metal chloride, because it'll be a, a compound, plus oxygen. Okay, so the metal in this particular problem is calcium, and that's all you have to do. Anytime you see chlorate, you know you're going to put this in the products, okay? Strontium hydroxide, that's another one of our special conditions. So anytime you see hydroxide, okay, anytime you see hydroxide, you're going to have the metal and you're going to have the metal with oxide plus water. Okay, so anytime you have hydroxide, you're always going to have this part. And the metal here in this case is strontium. Okay, so it would be strontium hydroxide would yield strontium oxide plus water. Okay, so anytime you see chlorate, you'll have chloride and oxygen. Anytime you have hydroxide, you'll have oxide and water. And then carbonate is our last special decomposition. So anytime you see carbonate, you're going to have its metal plus, actually not plus, but the metal oxide plus carbon dioxide. Okay, so the metal in this case is lithium. And that's how you do all of these special things. So anytime you have carbonate, you'll have this in the reaction. Anytime you have chlorate, you'll have chloride plus oxygen. So a metal chloride plus oxygen. Anytime you have hydroxide, you'll have a metal oxide plus water. Anytime you have a carbonate in the reactants, you'll have a lithium oxide plus carbon dioxide in the products.